here. All right, so we factored the first one, the red one. That one we checked by multiplying it back out, and it worked. The next one we factored out what's called a GCF because there was a 2x in both of them. And then to check it, multiplied it out. The third one, you also set up two sets of parentheses, but you don't start with x and x. I mean, you could say that you start with that, but then you quickly have to do more. So, Matilda, can you tell us what to do on the green one?
What do you do? 2x and then
2x and then, hold on, what's the other one in the front?
And then just x.
Very good. And is it plus and plus or minus and plus or minus and minus?
Plus and minus.
If you do that, you'll get a negative here.
Okay, then plus and plus.
Okay. And now, the last one. There's only two things that multiply to 1.
1.
Yeah. Now, how do I know I'm right? I don't until I check it. Natalie Ashlyn, how do I check that if this is right? All right. Especially this part. You could multiply the whole thing out, but especially this part, you got to check and see if the middle comes out. So we get 2x for the outside ones and x for the inside ones. Total of 3x. Yay, it worked. Okay. Now, there was some other kinds of factoring that were more weird. Everybody try factoring this one. Alisa, tell me how to start. Here and here.
X.
All right.
And x minus.
All right. There seems to be still some debate on like that because that's the most common mistake is whether it's plus minus or minus minus or plus plus. So you did it right. How did you decide it was going to be plus minus?
Because it's a negative.
Be specific. There's two places there could be a negative because the last number is negative. And if the last number is negative, there has to only be one negative. If the last number is negative, only one of these two spots can be negative. Okay. Amelia Erickson, how do you finish it off?
You would put 10 in both of the extra spots.
You got it. So x minus 10, x plus 10. All right. Here's another one that is similar to that. And let me think. Minus, sorry, change that to 6x squared minus 24. Everybody factor that one. All right, I know some of you were smart enough to go, those are both even. I'm taking a 2 out. But there would have been something smarter than a 2. Luke Scrivseth, what goes into both of them that's bigger than just a 2?
Would it be a 6?
It would be a 6. So 6 comes out, and then you go divide them both by 6. And let's have Alex Stone take it over. If you divide both parts by 6, what do you get left? Here and here. It's clearly a minus in between them.
X.
All right, and that's a really common mistake. Multiply it back out in your head. Like, do this quick and go, did I get the right answer? There it is. See, all it takes is a quick multiply it out once you see it on paper, and then you're like, oh, that can factor again. X squared minus 4 is one of those special ones. Everybody go ahead and factor that further. Angelina Fisher, what am I talking about? Factor it further.
You would have x plus 2 and then x minus 2.
You got it. Nice job. And that gives us the final factored form. Now, some people get confused with, okay, I don't get when it says solve. If it said solve, it would say equals 0. The whole thing would have been equal 0 the whole time. And then you'd go x equals negative 2, x equals positive 2. Because positive 2, when you put it in here, makes it 0. And negative 2, when you put it in here, makes it 0. These would be the solutions. All right. Now, let's get back to the hardest kind that you just learned yesterday for the first time. I go like this. Factor this. 3x squared minus 23x plus 7. Whenever it's intimidating like this, the numbers are all gross, just look and see, is there anything in common with all of them? And if there isn't, which, given there's a 3 and there's a 7, there's nothing that can come out of everything. That's your first step, is like, can I make the numbers all smaller by taking something out? GCF, is there a GCF in there? And there is not. Then you just one step at a time, you go like this. And then you ask yourself, okay, what do I have to start with? Again, each little question isn't that bad. So, Bertha, what do I start with in the blue circles?
Start with the 3x squared and distribute it into the parentheses. It's going to be 3x and x.
Very nice. Next, you have to decide whether it's minus minus, plus minus, or plus plus. No, wait, nope.
Minus.
Okay, you are right, Bertha. I was going to call on somebody else, but you were right. Very good. You're too good at this. Okay, Vikram, how can you be sure she's right on the minus minus thing?
Because the last number is positive.
Okay, but I could have used plus plus for that too. Middle number's negative. If you want this smiley face of factoring to come out right, it's got to come out to a negative, so you're right. They both need to be negative. And Vikram, why don't you finish it off? There's only two things that make a 7.
1 and 7.
All right. And you can see how it might have started looking really scary, but there was only one logical thing to do at each step. Now, the only question is whether it's 7 and a 1 or a 1 and a 7. Because it makes a difference. It's either 3x minus 1 or 3x minus 7. Now, you can kind of, once you get good at this, look ahead and decide, I'm going to strategically think about this and go, do I want it to be times on the outside part of the smiley face? Or do I want the 7 to be on the inside part of the smiley face? Jack Lewinsky, use strategy. You think we should put the 7 on the outside or the inside? Remember, our goal is this. Focus on your goal. We want negative 23. In the end, we can just try one. Remember, if you get it wrong, we just got to switch them around. So,
just try it on the inside then.
All right. So we'll do a 7 here and a 1 here. Now you tell me, what's the outside make, Jack?
3x or negative 3x.
Negative 3x. What's the inside make?
Negative 7x.
Does that actually make negative 23x?
No.
No. So now we know what? We got to switch the signs? No, that's if we had the exact opposite of what we wanted. We don't have 10 and 23 aren't even close to opposites. So, Jack, what do we do?
You gotta switch the numbers.
Yep. So you had 7 first on the inside. So we'll try the 1 on the inside and the 7 on the outside. Now, what do you think?
So now it would be negative 21x and negative 1x.
What's that make?
It wouldn't work.
It wouldn't work. Dang. That is going to happen to you. I'm pretty sure that one of our questions on the test is going to not be factorable. So you need, if I had made this a 22, then this would have worked. but they don't always factor. And I don't want you to think you're losing your mind. If you follow all the rules, it had to be 3x and x. That was the only way it could be. It had to be a minus and a minus. That was the only way it could be. Because to have a negative inside and a positive outside, that's the only way. And a 7 and a 1 was the only way it could be. We tried it this way. The only other way is to reverse them. And if you use 1 here and 7 here, we get negative 21, and then a negative 1 that makes negative 22. So close, but this doesn't work. That means there's a name for it. Things that can't be factored are called prime. That's what you write if the thing can't be factored. Now, I will tell you, here's a common mistake. Once kids have that happen, whenever they get stuck on a problem, they write, oh, this must be one that doesn't factor, and they write prime. If that happens to you a lot on the test, it's because you're just not doing it right. We don't put in a lot of questions that won't factor. We might put in like 1. Okay, so if you're getting a bunch of them that won't factor, it's because you're not trying the right combination. But if there's only 1 that doesn't work, it's probably prime. All right, let's try this one. It's going to be similar. 3x squared minus 25x plus 8. Now, if anybody said, I think I got it and this is it, I would check them. And I go like this. 3x times x, 3x squared. Cool. Then I would check the lasts right away because that's super simple to check. And negative 8, negative 1 makes positive 8. Sweet, that worked. Now the part that usually messes people up. These two. And I'm going to check it. Negative 8 times 3x is negative 24x. And negative 1 times x is negative 1x. And I put them together, I get negative 25. I know it's right. Nice job. All right. So today, given my massive tech issues here, I think we're just going to keep it simple. I want everybody to jump into the Schoology quiz that I made for today. There's a PDF of it so that you can try, do your guesses and checks on that. So I want everybody to get the PDF open and start there. Once I have most of the class done with the first couple, and Mrs. N, I'm going to need you to be my eyes on this. Just have them get the PDF open, have them do the first couple by hand on the PDF. And once enough kids have got a few to enter, I'll open up the Schoology quiz.
Okay.
Okay, so let's see how you're doing. If you look up on the screen, you'll see I've got the same PDF as you do. I hope you knew that this was 4x minus 7a times 4x minus 7a. And we're trying to make it a little bit of a challenge. So let's just distribute this out. That becomes 16x squared. And then 7 times 4 is 28, so negative 28. And it could be ax or it could be xa. It doesn't matter. Then this times this, which makes another negative 28 ax or xa, doesn't matter. And then last but not least, plus 49a squared. Now, I'll put these together, and I got 16x squared minus 56, because 28 and 28 makes 56, ax, and you could have said xa, plus 49a squared. Now, it says put the x term first and the a term last. So I got that. I got this first, and I got the a part last. And then you just type that in. Now remember, you have to use the caret key. And so to type this in, you go 16x caret 2 minus 56ax plus 49a caret 2. So there's your first answer that you're going to put in on the Schoology quiz. The second one. Let's go with Nick Richards. What is in all of these? And don't just say 3, because there is a 3, but there's more.
3m.
Very good. 3m comes out first, and then we figure out what's left. Remember, you can divide each part by 3m. So I'm going to show a little divide 3m here, and here, and here. And you should have m. And if you think you're not sure if that's right, just multiply it out. 3m times m, 3m squared. Cool, I'm doing it right. Plus 3m times what? And that's the way I do it. I think, what should I put here so that if I multiply it out, I'll get 12m. All right. And then we need one last thing plus something else. All right, Mrs. N, are they mostly done with problems 1 and 2 as you look around? All right, cool. I'm going to release the Schoology quiz now, and I'm going to ask you all to jump in there. All right. So at this point, I'm recording the video here. I just am telling kids that they should work on this Schoology quiz. It's the homework, and it basically sees if they're good at factoring at this point. Not trying to teach much new today, just kind of making sure they cover all the different kinds of factoring we've learned and get really good at it. Always check them by multiplying them back out. And if your factors multiply back out to the original, you probably did it right.